Hi guys, and welcome to this class. So as usual, we are going to be discussing the blood disorder. And the blood disorder we are going to be picking for today is leukemia. So leukemia is actually what we used to refer to as blood cancer. And the question is, why do they used to call it that? Before the ending of this class, you are going to understand that perfectly. So without wasting much of your time, let's just dive into the video. Yeah, welcome back. Now, talking about leukemia. Leukemia. Now, you see, most of the times we used to use the linguistic approach to define our conditions. So dividing the word into like leuk and emia. But one thing about these is these will not give us our definition. The word leuk in front of this strictly means the white blood. So the white blood cell. So leuk actually means white and emia means blood. So that is telling you that leukemia strictly means the white blood. So the white blood cell, sorry. Now the point is, if we are not going to be able to use the linguistic approach to demystify the meaning of leukemia, so the question is, what then can we use? We can just use this common definition. You see, the common definition for leukemia is blood cancer. Blood what? Blood cancer. And now, the question is, what is blood? We all know the meaning of that. Our blood is talking about the white blood cell, the red blood cell, the platelet, the plasma. But what about this guy here called the cancer? Cancer normally, cancer is an excessive proliferation. Excessive what? Let's say excessive and uncontrollable. That is the word. Excessive and what? Uncontrollable proliferation. Good. Proliferation of cells. That is what cancer means. Cancer is actually what? The uncontrollable proliferation of cells. So the meaning of that is, if you have a cell right now, normally the cell is meant to grow or to divide rather into two cells. And then from the two, this guy becomes another two cells. This guy becomes another two cells too. And the proliferation ratio continues. You see, in cancer, the proliferation is affected. So in such a way that it becomes highly exaggerated. These cells, they are going to be proliferating uncontrollably. So you have a lot of cells. A lot of what? A lot of cells. But the point is, even after having a lot of cells, do you think the proliferation means multiplication, duplication of cells. So do you think when you have a lot of cells in cancer, the proliferation stops? No. The problem is this cancer. It keeps on proliferating. That's why we call it an excessive. It's just too much. And uncontrollable. We can't control it anymore. So uncontrollable proliferation of what? Of cells within the body. Now, if you combine the meaning of blood and cancer together, you already know the reason why they call blood leukemia the blood cancer. What is happening here is just an excessive and uncontrollable proliferation of what now? Of the blood cells. As simple as that. Now, the point is, the definition is not complete. If you called leukemia an excessive and uncontrollable proliferation of what? Of blood cells. To make it perfect, you see, the kind of cell that are proliferated in leukemia are immature cells most of the time. Whereas sometimes the cells are going to be matured, and the point is, they are not okay, they are not genetically fine. So we'll talk about that later. Now the point is, to remodify the definition of leukemia, you can say it is an exaggerated, that's for excessive, an exaggerated and uncontrollable proliferation. But of what now? Of immature blood cells. As simple as that. So this can be said to be a perfect definition. And one thing is, you can introduce things about this definition. And what are those things you can introduce? I'll get to that in a jiffy. But Before we proceed, let's take a look at the blood cells itself here. What we can take a look at about these blood cells is that we say blood cancer or leukemia is an exaggerated what? Exaggerated and uncontrollable what? And uncontrollable proliferation of immature blood cells. The question is, which of the blood cells? Is it white, is it red, or is it the platelets? For you to know that, talking about immature blood cells, this is actually talking about the initial stages of production. The initial stages of what? Of production. Now, let's quickly take a look at the initial stages of production of what? Of blood cells. But specifically, we're talking about the white blood cells. Now, let's go. Do you want to produce a white blood cell? We know that what you need is to start with a what? Hemocytoblast. Okay, let's denote them with the cells. So, hemocytoblast. So let's say this guy here is the what? Hemocytoblast. Hemocytoblast is going to divide to become either the myeloid stem cell, myeloid stem cell, become the what? The myeloid stem cell, or it divides to form the what? The lymphoid stem cell. Lymphoid stem cell. Now, from there, let's assume that we want to form the what? The granulocyte right here. We want to form the granulocyte. You already know that all you need to come first, to produce first, is that this myeloid stem cell is going to form something called the myeloblast. 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 And from there, it divides to form the pro-myelocyte for the three guys. So, we have the basophilic pro-myelocyte. We have the eosinophilic pro-myelocyte. And we have the what? We have the neutrophilic pro-myelocyte. And from there, the basophilic pro-myelocyte will divide to form a new cell. And the new cell it is going to form is the what? The basophilic myelocyte. And this guy will form the what? Will form the eosinophilic myelocyte. And then this guy is going to form the what? The neutrophilic myelocyte. Now, after that, they become what? The original cell. This guy becomes the basophil. Staying with blue dyes, this guy becomes the eosinophil. That is red. So, eosinophil. And this guy is neutral. So, we call it the neutrophil. Because it can absorb both the what? The blue and the red dye. So, neutrophil. Now, after that, the lymphoid stem cell mainly, it can divide to form a new cell called what? A lymphoblast. You know what you want to form from here is your what? Is your lymphocyte. Lymphoblast. And from there, the lymphoblast divides to form a new cell. Excuse me, guys. Sorry. I've forgotten about the stages. So, no, I'm right. Sorry. Lymphoblast. Yes. It's actually from dash blast, pro dash site, and then the site. Good. So, here now, we're going to have the pro lymphocytes. Pro lymphocyte. And from the pro-lymphocytic level, it becomes the what? The lymphocyte. Now, this is just a schematic diagram, not a real diagram of these cells. You know they have the nucleus, and the nucleus are not going to this dot. So, down aside. So the point is, apart from that, you have one more cell to differentiate into. And that is what? That is the monocyte. Firstly, it becomes the what? The monoblast. Monoblast. From the monoblastic level, it becomes a what now? It becomes a pro-monocyte. And then it becomes the what now? The monocyte. So, this is just the development of what? Of the white blood cells generally. Now, what do we need from this? What concerns this guy? The what? With the immature blood cells. Now, taking a look at all these diagrams, Which of the following cells on this half of the board are the what? Are the matured cells. The mature cells do not stretch themselves are the what? The lymphocytes. Because it's going to become the B cell and the T cell later. They are matured. They can perform their responsibilities. Now, the next one is what? Monocyte. Monocyte is a matured cell. And then, neutrophil rather, is a matured cell. Eosinophil is a matured cell. Basophil is a matured cell. You see, anything below all these ticked guys, they are all immature cells. Up onto the what? Up onto the myeloid and the lymphoid stem cell. The point is that hemocytoblast itself is a mature cell. That is the reason why it can divide to what? To form new cells. And that is the reason why in mitosis, when we are defining it, they always give us a factor that we must put in that what? In that mitosis. They say mitosis is the duplication of a matured cell. Don't just see a cell. So the matured cell form what? This and that. Now, there are a lot of controversies concerning what I'm saying right now. So let's keep it aside. For people who want to do arguments, it's very good. Academic argument is good, but that one aside. Now, back to work. The point is, right from this level, up onto this level, they are all immature cells. And now you see, we called leukemia or blood cancer. We define it by saying it is an exaggerated and what? Uncontrollable proliferation of what? Of immature blood cells. Which means leukemia only affects what? Immature blood cells. It doesn't necessarily affect what? Things like basophil, eosinophil, neutrophil, monocytes, and lymphocytes. Now the point is, why are these guys sick? Why are they not affected? It is simply because the uncontrollable proliferation or the uncontrollable development or the uncontrollable growth we are talking about here affects mainly this cell right here and this cell. Coupled with what? This cell. Now what is the meaning of that? In leukemia, what happens to the stages of what? Of blood production. Now, let's start from this side. If you want to form what? Granulocytes. This is your pathway. Up onto this vein, the granulocytes, right? Now imagine that as this cell, this hemocytoblast, divides to form the myeloid stem cell, something happens to the myeloid stem cell and it becomes unable to progress to form things like myeloblasts. Just think of that. Imagine that something happens to what? To the myeloblast, if at all it is formed. And then it prevents these myeloblasts from moving forward to all the stages. The point is, if something is arresting this growth, it means hemocytoblast will only be producing more myeloid stem cell. And for you to understand this thing better, the point is, think of the fact that you want to produce white blood cells from our leukopoiesis. Imagine that there is a reduction in the what? In the granulocytes. Or they are needed to be formed actually. Because there are some granulocytes that spend just days in the body. Days, 3 days, 5 days. Down the side. The point is, if there's a reduction in the granulocytes, you already know what will happen. The point is, impulses are sent to the what? To the reds. Reticular tissues. And what it does to release their what? Their granulocytic stimulating factor and their what? Interleukin, specifically anyone it happens to be. Now the point is that these guys now, they are going to go down now to the bone marrow to make the what? Hemocytoblast. And they will tell hemocytoblast to later form what? To later increase the what? The amount of granulocytes in the blood. The cell will be produced at last. And when it gets produced, so the count of what? Of granulocytes what? Increases one more time. As in once again. Now imagine that there's a reduction in the level of granulocytes. Reticular tissues, they release GCSF and interleukin. And it acts on the what? On the hemocytoblast. And the hemocytoblast divides to what? To form the myeloid stem cell. Now guys tell me, after the myeloid stem cell, this guy is meant to divide into what? Into myeloblast. Because we want to form what? We want to form granulocytes, right? Now the point is, imagine that this is arrested here now. And the myeloid stem cell cannot further divide to form all these things. What will happen to the level of granulocytes? Is it still going to be high or low? Because we are unable to produce all these guys, the granulocytic level is still going to be what? It's still going to be low. And force impulses again, this is low level, will be sent to Red. They release this, they affect the water cytoblast, and that keeps on and instead of producing more granulocytes, it still got arrested at this stage. If it got arrested at this stage, it means we have what? 2 myeloid stem cell now. I understand that, guys. Apart from that, think again. One of the second pathway again fails. Is unable to proceed. At the end, you are still going to have a reduction in this guy's level. And that reduction will send an impulse back to the what? To the cytoblast. And it still release another what? Another myeloid stem cell. Are you with me, guys? And this keep on occurring and occurring and occurring until you have a lot of what? A lot of myeloid stem cells, and they are not going anywhere. And they keep on producing, as in they keep on being what? Being produced uncontrollably. The point is that when this kind of things occurs in the bone marrow, this is what we call leukemia. But we have types of leukemia. I'll talk about that in a jiffy. But now imagine that you want to form a what? You want to form a lymphoid, a lymphocyte. If you want to form a lymphocyte, this thing is going to happen all over again, although that should be an granulocytic clone stimulating factor. The point is, when these lymphoid stem cell, when they keep on what? Being produced, but they cannot progress to the what? To the next stage, which is the lymphoblast. That is actually another type of leukemia. And apart from that, in some other type of leukemia, these guys are able to what? To accelerate to this third stage, lymphoblast. And when they reach there, they are unable to move to the what? To the pro-lymphocytic level. And therefore, you have a lot of what? Lymphoblast. As simple as that, guys. This is just partially what is happening in what? What is happening in leukemia. When we say leukemia is a what? Is an exaggerated and uncontrollable proliferation. We cannot really control it because something is happening to these cells. These cells are unable to divide to the next stage. What is happening to them? You will understand that in the etiology very soon. So the point is, there is what? An uncontrollable proliferation of these cells. And of what? Immature blood cells. They are immature because they are even unable to produce what? The red cells. Now, that is what is happening what? In the definition of what? Of leukemia. Now, I'll rub the board and then we'll talk about the types of leukemia. And afterwards, the etiology. And we'll conclude the video with the pathophysiology. So, I'll be right back, guys. Yeah, welcome back. Now, talking about the types of what? Of leukemia. So, to understand that perfectly, we still have to come back with the illustration of the what? Of the leukopoiesis. So, quickly, just take this as a form of revision. So, the first cell ahead is the hemocytoblast. Cytoblast. And from there you have your what? The myeloid stem cell. So myeloid stem cell. And right here you have your what? Your lymphoid stem cell. Lymphoid stem cell. And from that, if you are creating a granulocyte, you will have a myeloblast first. Myeloblast, and then the myeloblast will start dividing to form the 3 cells, or let me say the precursor of the 3 cells. So you have the first one, which is your what? If this is myeloblast, promyelocyte now. Basophilic promyelocyte, and another one eosinophilic promyelocyte and neutrophilic promyelocyte. And from there, it graduates to become a myelocyte proper. So you have basophilic myelocyte, you have eosinophilic myelocyte, and neutrophilic myelocytes. And finally, they are going to become what? The normal cells. Although they pass through a stage called the band cell when they are released into the bloodstream, but forget about that for now, guys. So we have your basophil, you have your eosinophil, and you have your what? You have your neutrophils. Cool. Now, if you want to make another type of cell called the what? The monocyte, it creates a different cell entirely, and that is what? Monoblast rather, monoblast, monoblast. And after that, the monoblast transits, it changes to become the promonocyte. Promonocyte. And finally, it becomes what? Monocyte. And right here, the lymphoid stem cell can become the what? The lymphocyte. But firstly, it divides to become the what? Lymphoblast. Lymphoblast. From there, it becomes a pro-lymphocyte. Pro-lymphocyte. And then it becomes a lymphocyte. Lymphocyte. Cool. Now, guys, the point is, what are the types of what? What are the types of leukemia? Excuse me, please. So, to understand the types of leukemia, what you need is just to know some certain things from you. I told you from the last thing, when we illustrated this on that part of the board, that you can have the duplication or replication of what? Of this myeloid stem cell. You see, when leukopoiesis cannot pass beyond this stage, what happens is that the myeloid stem cell is the one in soup, the one that goes haywire, so the one that is in trouble. And that type of what? That type of leukemia, where the myeloid stem cell is the one affected, is called, let's come down here, guys. So, we're talking about the types of anemia now. Sorry, types of leukemia. Types of leukemia. Now, broadly, it can be divided into acute and chronic. So, I'll explain everything later when we are done with the explanation of this. So, normally we have acute and what? And chronic leukemia. And chronic. Now, under this acute, we have two types. We have acute. Once this myeloid stem cell is affected, the first one is called acute myelogenous. Myelogenous leukemia. Now, the word myelogenous is for the word myeloid stem cell. So when myeloid stem cells are affected, so they call it acute myelogenous leukemia. Now, apart from that, for this chronic side, we also have chronic myelogenous leukemia. So the M is also for myelogenous, but for myeloid stem cell rather. But the question is, when is it acute and when is it chronic? I'm coming down to that later. Now you see, we also said this cell as well, this lymphoid stem cell, it can be the one affected, and the production of white blood cell will not go beyond the stage. So when it can't go beyond the stage and proliferation keeps on occurring right here at the lymphoid stage, this actually belongs to what? It belongs to excuse me guys, there is one thing I want to actually point out, but leave it for now. I'll come back later. So that belongs to what? That belongs to the acute side here, and you call it acute lymphocytic for now. Lymphocytic. So acute lymphocytic leukemia. And now, what next? We are going to be left with just a single division right here. So we have CML here. Now, you see, the cell, this lymphoid stem cell, can actually proceed to this lymphoblastic level, but then not being able to go to the what? To the pro-lymphocytic level. When it is arrested at this end, when this guy, this lymphoblast, when it duplicates uncontrollably, we call that chronic. Since we're on the chronic side, we call it chronic lymphoblastic leukemia. Lymphoblastic leukemia. Excuse me. Leukemia. So guys, these are the what? The main four types. Underline the word main. So we have more. But mainly, we have four types of what of anemia. Oh, sorry, of leukemia. Please, I don't know why I'm using leukemia and anemia interchangeably. Just for this video, take note of that. So whenever I hear anemia, just look at what I called it. Whenever I say leukemia, just look at the context in which I'm talking. So that's aside. So we have acute myelogenous leukemia. We have acute lymphocytic leukemia. Excuse me, guys, this is wrong. So now I made a mistake right here, and the cheat for correcting that mistake, I will teach you as well, so you don't make exactly the same mistake. Now, what is that mistake? This is it, guys. I know for sure within my mind that we have myelogenous leukemia, both acute and chronic. So you already know that one, we have acute myelogenous leukemia, and I'm sure we have chronic myelogenous leukemia. So no stress, we are done with the first thing. You see, the last two, they are both acute. Sorry, they are both acute and chronic. So the third one is acute again now. And now the problem is, I know the fourth one will also be chronic. Now, how do I know this is acute lymphocytic or chronic lymphoblastic? If they happen to have the same origination, we would have said acute lymphoid leukemia, chronic lymphoid leukemia. But one is for the lymphoid stem cell, another one is for the what? Lymphoblast. And that creates a kind of turmoil, a kind of trouble. I have to decide right away to make sure I don't make this kind of mistake in exam conditions. The point is, you see this C is chronic, right? That C is the one that goes with lymphocytic, like letter C, lymphocytic. So the chronic is for what? Chronic lymphocytic, lymphocytic leukemia. So you see, the chronic, the C, will make you remember that it is the lymphocytic. That was why I was damn sure that this should be acute lymphoblastic and not acute lymphocytic. So change these to what we have here now. And what do you think we have here now? That will go for the lymphoblastic. Acute lymphoblastic leukemia. So these are the what? The four types of leukemia that we have. Now the point is, we understand myelogenous affect the what? The myeloid stem cell. Good. We understand that lymphoblastics affect the what? The lymphoblast. We understand the lymphocytic affect the what? The lymphocyte mainly. So, excuse me guys, one issue right here. Okay. Yeah, the lymphocytic affect the lymphocyte. So, but one thing is, if you have lymphocytic, this chronic lymphocytic leukemia, you have your lymphocyte being produced, like the B cells, the T cells. But the point is, they are actually matured one. But because they are matured, does not mean they will do their job. Now, I know you'll be confused now with everything I just did. But let me actually fine tune this so it gets better. You see, in some textbooks, so we'll find it in other textbooks. So this leukemia, we have acute and what? And chronic. Cool. I know you understand that. Now, what about the leukemia that affects the myeloid stem cell? That it has no controversy at all. No issue. Very easy to understand. The point is, they are called acute myelogenous leukemia and chronic myelogenous leukemia. No stress at all. Now, what about this lymphoid stem cell? If issue occurs at this lymphoid stem cell, instead of what? Of some other textbook giving you things like acute lymphoblastic, chronic lymphocytic, the point is, they just tell you acute lymphoid leukemia and chronic lymphoid leukemia. As simple as that. Talking about the lymphoid precursors, as simple as that. But one thing is, the reason why we used to use this, although it's a little bit confusing, is because they're the most common type. Now, I will explain them just one more time so you understand. You see, the issue we have with this is the maturity of the cells. So whether the cells are mature or not. You know, I told you in the last thing that even some cells can be matured. Now, let me come back one more time to explain this. The point is, I do not think I have to explain things like acute myelogenous and chronic myelogenous again for now. In fact, they call them myeloblastic in some textbooks. So I don't want to stress you about that too, because that will lead us to the progression of the myeloblast as well. Talking about forming these guys in the blood, but the fact is, yes, they are mature, but they can't do their job. Now, leave that one aside about maturity. Maturity, we understand where it comes in now. When you have acute lymphoblastic, the lymphoblast is what's affected. This is where the growth stops. The lymphocytes are what you have. Are you with me, guys? So, but if you have chronic lymphocytic, the point is, here is where the growth stops. But the point is, you have a lot of it, making it a cancer. And then they cannot really perform their function because they are not perfect. They are already damaged inside. You understand that in the etiology. Now, why do they have acute lymphoblastic and chronic lymphocytic? When these two guys can actually be a little bit confusing. The point is, they are telling you that leukemia can be made up of both matured cell and immature cell. The point is, if you have acute lymphoblastic, tell me, is lymphoblast a mature cell? No. So, in acute lymphoblastic leukemia, the point is the cells are immature. This can even be an objective question for you. Like, which of the following has a mature cell? Which of the following leukemia has a mature cell? So, I know the lymphoblastic is out of it because it's immature. But in chronic lymphocytic leukemia, you have a mature what? You have a matured cell. As simple as that. Now, guys, now you understand what? The types. The point is, what is the meaning of the acute and what is the meaning of the chronic? This is not our first time talking about that. If you've been with us from day one. So when you say acute means something that occurs suddenly, rapidly. So the division is very fast. But chronic, the division is slow and what is progressing, it progresses gradually. So acute is for rapid and then chronic is for gradual proliferation. As simple as that. So now, once you understand the types, let's talk about the etiology of leukemia. What causes leukemia? So, Abraham, guys.